we're talking about finding equations of exponential and logarithmic functions. Okay, here's our first example. The rule describing the graph shown is in the form y equals a e to the power of x plus c, and we want to find the values of a and c to 4 decimal places. So you look at the graph here and you can see they've given us 2 points. The 2 points that they've given us, you can see this point here, x equals 5, y equals 13, and this point here when x equals 0, y equals 3. So looking at our equation, we can actually use those points to substitute into the equation. So I'm substituting when x equals 5, y equals 13, that gives me my first equation. I'll do the same thing with the other point. When x equals 3, when x equals 0, y equals 3, and that gives me 2 equations with 2 unknowns. How am I going to solve these equations? This is a simultaneous equation. I'm going to subtract equation 2 from equation 1. What do you notice? I can take a out as a common factor, and I end up with e to the 0. E to the 0 we recognize as being equal to 1. So a equals 10 over e to the power of 5 take 1. Now obviously they've asked us this to 4 decimal places, so we're going to put it into our calculator, and that comes out as 0.0678. Substitute that number back in to one of the equations, probably equation 2, because that's the easiest, and you should be able to get c equals 2.9322. So that's telling me that the equation for this particular graph, y equals 0.0678 e to the x plus 2.9322. Okay, let's try another one. This one says find the value of a and k, again to 4 decimal places, given that y equals a e to the kx. Notice k is in the power, is in the index this time. So you look at the graph here, again they've given us 2 points. Here's the point when x is minus 1, y is minus 4. Here's the point when x is 3, y is 8. So substitute those values in. When x is minus 1, y is minus 4. When x is 3, y is minus 8. Again we have 2 equations. This time I'm going to divide equation 1 by equation 2. Why do I do that? You remember with powers, when you divide the powers, the a's cancel out here, so you can see here the a's cancel out, and e to the 3, when you divide that's the same as subtract the powers. So kx minus k e to the 4. Just notice there that I've actually left a negative sign off here. That should be e to the negative k, and that's where this negative came from. That becomes 2 equals e to the 4k. We're asked to solve this, to 4 decimal places. 4k equals log e to the 2. Put that into your calculator, solve, and k equals 0.1733. Substitute that back in to your original equation. Either one of these equations up here, and you'll end up with a equals minus 4.7569. And that gives us the equation of that particular graph. So this graph here, y equals, go away, y equals minus 4.7659, and undo that last thing, e to the power of 0.1733 times x. Okay, last one. Again, they've given us 2 points here, x equals 4, y equals 0. Up here, it's just off the edge of the page, x equals 6, y equals 18. This time we're putting it into the form y equals a log x e to the x minus b. Well, that's what we're putting the value into. There's our first point, x equals 4 when y equals 0. There's our second point, x equals 6 when y equals 18. This time, instead of adding or subtracting, we're going to actually try and solve, find a value here. So I'm going to make that equal to 0, divide by both sides by a, the a cancels out. That gives me e to the 0 equals 4 minus b, 1 equals 4 minus b, so b equals 3. I can then substitute that back into the other equation, equation 2. B equals 3 in this case, so 6 minus 3, 18 equals a log to the base e of 3. A equals 18 divided by log to the base e of 3. Put that into my calculator, 16.38. So you can see it's actually quite a simple process. In every case here we're doing simultaneous equations. We're either using substitution or division, making two equations from our 2 points, and then using simultaneous equations, substitution, to solve